All right. Good day, everyone. I'll be presenting about advanced BIM modeling as regards MEP towards quantity takeoff. This project was supervised by Claudio Miraci, and I had incomplete tutors Giuseppe McGinney and Frigo Maki. So first of all, we're going to go through the presentation structure. We are going to present about the problem statement and the goals. We'd also talk about some key concepts that we realized. I think it's worth sharing, and also go on to talk about the proposed process flow for this project, and then go through the case study itself, and end up with our conclusions. So the problem statement, there's been a lot of advancements when it comes to the use of BIM in the built industry, and this has also impacted on how we generate our quantity takeoffs. However, there's the proliferation of BIM has also created some form of fracture, and that has resulted in poor software integration, loss of time, and also loss of information during exchanges. The goal of the project the aim of the thesis is to develop an integrated MEP quantity takeoff process that address these concerns by integrating the software platforms for calculation and modeling, and also creating interoperability between information modeling and quantity takeoff platforms through IFC Exchange. And then finally, bringing all this together with the price list information and WBS cost definition on the QTO platform. So we're going to talk about briefly about the concept of information requirement under ISO 19650, which is the international standard for managing information over the built asset lifecycle. When an organization identifies a strategic need for a built asset to meet their organizational goals, this need is documented and is also referred to as the organizational level information requirement. The expression of this organizational level requirement oftentimes lead to asset and project level information requirement, while asset level information requirement is triggered by events during the asset operation. Project level information requirement is usually triggered at key decision process points during the project execution itself. Both AIR, which is asset information requirement, and PRR informs a set of managerial, commercial, and technical project information, which is known as information exchange, which is here and is usually prepared for each appointed party. In response to this, we usually have the appointed party prepare documents that is referred to as the BIM execution plan, outlining how the project information model and asset information model is going to be delivered in alignment with the employees' information exchange requirements. About the typical workflow, this represents the typical workflow that leads us to quantity takeoff, as summarized by major work stage standards. We usually would have it start with the preliminary calculation and spatial programming, beginning each of the process, and then at the end of each of the stage, it ends with coordination, clash detection, and resolution. And then the next one basically improves on the previous stage until we get to the point of quantity takeoff, which ends the process. The work stage for the proposed process workflow, the work stage is unchanged. However, what we've done is to propose a flow that responds to the integration of activities um, between calculation and MEP modeling, and then going on to model view definition and exchange requirement, and then quantity takeoff itself. The yellow labels are inputs that go into each of these stages to help to optimize the process. And the green labels are usually the outputs that we get from each of the stages until we end up with the QTO document. The case study we worked on is a project that is set in Milan. It's an 18-floor residential building, 110 apartments. It has three cores, and each one 18, 16, and 9 floors. We think Energy was the appointed party for the photos services, but for the purpose of this presentation, we're going to focus on sanitary water system and with wastewater disposal, because the process can be adapted to the other systems that they've been appointed to supply. For MEP calculation and modeling, it happened simultaneously, and model was done in Revit and calculation was done using spreadsheets. For wastewater disposal, which is this calculation, the system starts with identifying the unit of discharge for each utility um, within a wet area. And once we are able to calculate for the total unit of discharge for each wet area, we know what that is, and then we're able to establish, using the rule of thumb of 4-meter radius, we're able to establish and locate discharge points within the layout of the floor plan. And this table shows a list of the discharge points that we have identified. When we add up all of the connected wet areas for each of the discharge units, we're able to, and then we combine that with we're able to find out the discharge unit for the discharge point. And then with that, combining that with the coefficient of frequency, we are able to find out what the flow rate for that pipe is, and then use the corresponding pipe size. Same thing applies for just a little bit of tweak when it's vertical. From when it's horizontal, we use 1% slope. For the domestic water supply, it's the same principle, except this time it's unit of charge. And this example provides for wastewater supply to an apartment on the first floor. And using a calculation, we can identify what the flow rate of the pipe is. And then we can use that to define what the pipe diameter is, and then use the next standard size pipe for that particular uh, water supply into the building, into the apartment. For the modeling, Revit was used, like I said before, and we used Revit families, except that it was um, cleaned up, and then we used the sizes and the fittings that is required for the project as specified by team execution plan, and also some certification, and also using um, codes and compliance and local compliances required by the law of the place that the building is situated. For WBS implementation, um, we had 7 levels of WBS, which gives the opportunity to categorize the quantities based on those different categories. And then to implement this in the model, we created a shared parameter, which with the WBS name we applied to specified objects. Using named scope boxes in Revit, we're able to isolate objects by space and assign WBS parameter to the objects within that space. For IFC exchange, we used PTO property sets that was used to extract geometrical data from the model. So we can see here things like gross cross-sectional areas, gross weight, length, net weight, and things like that. We also, for mechanical equipment, just to be sure that the objects go into the appropriate are mapped appropriately, we used IFC export as to specify where we want the objects to be mapped into. And also for verification purposes, geometrical quantities were extracted through Revit schedules and were assigned as user-defined parameters in while we're exporting. So this is what the parameters look like for the WBS as well. And then in exporting, we used IFC4 reference view because it's the preferred. It was preferred because it's the most improved geometrical representation property. It has the most improved geometrical representation properties compared to IFC 2x3. Also, the schedules were exported as seen here, and when the export was done, we did a validation with a few IFC viewers to confirm that the properties we exported are indeed what is in the file, so that when we get onto the PTO software, we have what we want. And the first thing that was noticed was that calculated values from the schedule were not exported. And with a few tries, everything was fine and good to go. For quantity takeoff, the process is such that we had a filter for price. We had a price list filter for the database. The price list that was used is the private price list that was gathered from the personal experience of the organization working with different contractors. So we used a filter from Revit using the unique categories, unique object types in Revit to do a filter of the price list. We got that into the project price list. We did the same thing using filters for the IFC object, and then apply the quantity takeoff rule using a unit of measurement to that, and then including WBS, we ended up with the PTO that we wanted. So the process looks like this in detail. This is a sample of the list of objects that we exported from Revit, and these are the codes for the price list. And this is what it looks like eventually when they were imported into the project, into the QTO software. For this purpose, the QTO software that was used was STR Vision. And when it comes to the filter, this is what the filter looks like.
Sorry to interrupt you. We are running out of the time. If you can make it faster to the conclusion, I appreciate it. Thank you.
Okay. Yes. So the export was done this way, and for the takeoff rule, using the code from the price, we were able to do a calculation to find out what for example, for this one, steel pipe, which requires to be measured in kilogram, use the calculation to find what the quantity would be in kilogram. WBS was applied to the QTO, and we ended up with the quantity takeoff. So in conclusion, we went through integrating the calculation and software. The advantage of using the spreadsheet and Revit was the platform agnostic solution that spreadsheet gives us. But the problem we encountered was sometimes bi-directional probability was a bit difficult. And I think that's something that can be looked further into. For the IFC exchange, we use 4.0 and user-defined work sets. Like I said earlier on, the calculations didn't come in. So I think exploring further how we can expand further the geometrical data values in IFC will be very, very useful. Finally, for the QTO, for further studies, I think that even though we've done this, oftentimes there's always the concern that it's not close enough to what the real cost of the project ends up being. So I think research into how you can have the project QTO come closer to the final cost of the project will be a very useful and valuable one. Thank you.